Hence we have the limits of the integral tending to infinity. We can break down the integral, so I'm going to split up the integral into two parts. And first off, I'm going to focusing on this expression to use substitution. So I'm going to name e to the x equals u, and the u should be ex dx, and therefore the x should be du over e to the x, but e to the x is u, so for u. And here, if you want to, we already have this dx and e to the x, and we don't have the x, so if we want to obtain this value, we can use this expression. So I'm going to use this. I'm going to apply ln here, and that should be ln of e to the x equals to ln of u, and therefore x times ln of e should be ln of u, and finally we got dx, which is ln of u over ln of e, and we know that this expression is 1, so x should be ln of u. And I'm going to first I'm going to use another undefined integral. So yes, I'm going to substitute here. So the integral of e to the x, which is the integral of e to ln of u, sorry, minus e to the x, which is u, and the x should be du over u, so du over u, and that is the integral of a ln of u over e to u, du over u. And here we know this expression should be 1 because we got e to log of u, like so. So this should be u, and we can replace this expression here. So it should be u of the integral of this over eu du over u. We can cancel out these terms, so the integral of 1 over u, and here we can move this term upside, so I'm going to do it. e2 minus u, and we can apply the limit here. So I mean, we can apply the integral rule. So and we can use substitution again here. So I'm going to name this this term like minus u. It should be, for example, a, and the a, it's minus the u, so the u should be minus the a, and we can continue here. So e to a of the a, I mean minus the a, So that's, and that is e to the a plus c with this minus here. So this is equals to minus e over a, which is minus u plus c. So once we have this, we can use the original term here. So we know that e to the x is u, so we can replace here. This should be e to the u, which is e to the x, and that should be the integral. So we're going to apply the limits to solve this original integral. So that is, let's continue here. That should be the integral from minus infinity to infinity of e to the x or to the x dx, and we know that this expression should be this expression right here. So minus e of x from minus infinity to infinity. So that should be this expression, minus c to the x, which is the upper limit, minus the lower limit, so this. And now we can apply in this first term this property. So it should be 1 over a to infinity, and here we know that e to infinity, it's infinity. So if this is infinity, that should be 1 over a, which is 0. So this is entire expression is 0, and the second one should be let me see, minus 1 over a to a minus infinity, which is this expression should be minus 1 over a over 1 over a to the infinity, and we know that this expression right here, it's 0. So that should be this over 0, which is 1, and with this minus it should be minus 1. So this entire expression should be minus 1, and finally we got 0 minus, because of this minus here, minus 1, which should be 1. So that is